Hi everyone, welcome back after our week of spring break. I hope you guys all had a great week off, and whether you got out of town and did something fun or hung out around town and just had a week to relax and take some time off school. I hope it was great for all of you guys, and we are back at it. So we are working in week 12 this week, and we're starting a brand new unit, which is exciting, kind of a fresh start after spring break, and we are starting with Unit 8. And we are going to be looking at different types of functions and how we can relate them all together eventually and find some different solutions. So this week we're going to start with square root functions. So we're going to start this week with Unit 8, Session 1. I am only going to assign a light week, only one session this week. It's going to be a light week of assignments, and that's because I know some of you are still testing, state standardized testing, and some of you that are testing can have a reduced load. I know some of you are testing next week, and I'm also going to have a lighter week next week as well. So a great opportunity if you are behind to take advantage of the light week as well. So keep that in mind. There's only 2 more months left in the school year. That's pretty exciting. So let's jump right in and start with the warm-up question. As I mentioned, we are going to start this unit with looking at square root functions. We're going to look at the graphs. We've never looked at the graphs of square root functions before. So today and this week we're going to look at what the shape of square root functions look like when they're graphed. But before we do that, let's hop right into a warm-up question and getting us thinking about square roots and how we solve them. So make sure you've got your math notebook before you do the warm-up. I do want you to do the math warm-up in your math notebook. What I would like you to do is calculate f of 3. So we're looking at a function for f of x when it's equal to square root of x plus 6. So remember, this equation right here is written in function format. And I'm asking you to find the f of 3 for the f function right here. So remember, that's just a fancy way of saying wherever you see a x, you're going to plug in 3. So go ahead and solve that, and then when you're ready to check your work with mine, well, I forgot to say that. Go ahead and click pause so that you can try this on your own, and then when you're ready to check your work with mine, you can click play. Okay. So as I mentioned, with function notation, when you have f of 3, that's just a fancy way of saying that x equals 3, and that whenever you see an x in the function, you're going to plug in 3. So f of 3 is going to be equal to the square root of 3 plus 6. And what is 3 plus 6? It's 9. And the square root of 9 is 3. So the function, when we plug in 3, will also give us an answer of 3. All right, I'm going to go on to the next slide. So if you need more time, go ahead and click pause. So this week, as I mentioned, we're going to dive right into Unit 8. Oh, by the way, I think I mentioned this already. There's only about 2 months left in the school year. That's pretty exciting. So we've got April and May, and that's it. So keep that in mind, that we're only 2 months away from the end of the school year. And then this week, I've already mentioned, we're going to look at square root functions. We're going to look at the characteristics of square root functions, more so the graphs, I should have said there. We're going to be looking at the graphs, the characteristics of the graphs, the domain and the range of graphs, as well as transformations. Remember transformations? We looked at that with quadratic functions, how we can move the graph up, down, left, right. We can shrink it. We can stretch it. So we're going to look at that, transformations of square root functions as well this week. All right, so square roots. Let's review some stuff. So first of all, our symbol, the square root sign symbol. So we call this symbol here. So this sign right here, which many of you it should look familiar to, this is what we call the radical sign or the square root sign. And then underneath our square root sign is where we put what we call the radicand. So like square root of 16. The number that we are taking the square root of is called the radicand. Just so you know the vocab, you will see this vocab in the lessons this week. And just want to make sure that when you see these words, you understand what they mean. So the radicand is the number underneath our square root sign. Something else to review, I'm going to pose this question to you. Can you take the square root of a negative number and get a real number solution? For example, can you take the square root of negative 81 and get a real number solution? So remember, a square root has to be a number times itself that gives us the radicand, or the number underneath the square root sign. So think about that. Is there a number that when we multiply the exact same number times itself, we can get that negative 81? Well, if we have to have a negative as our answer, I first primarily would think it would be negative 9, but then remember we have to multiply it by the same exact number, and a negative times a negative would give us a positive, so we wouldn't get that negative. So there is no way to get a real number solution of a negative number. So the answer is no. You cannot take the square root of a negative number and get a real number solution. So keep that in mind, that we can't take the square root of a negative number. Can we take the square root of 0? We can. It's actually going to be 0, because 0 times 0 equals 0. So you can, in fact, take the square root of 0, but you cannot take the square root of negative numbers and get a real number solution. All right, so what do the graphs of of square root functions look like? So let's create a little chart, our X and Y chart, and let's find or create the graph for the square root of X. So I know that I can take the square root of 0. I'm going to do numbers for X when I plug them in that I know I can find a square root of. So I know I can find the square root of 4, I know I can find the square root of 9, 16, and we'll do 25. So if I plug in 0 for X, what's the square root of 0? 0. What is the square root of 4? It's 2. What's the square root of 9? If I were to plug in X as 9 for X, the square root of 9 is 3. If I were to plug in 16 for X, the square root of 16 is 4 and 5. Oops, I forgot to do 1. I'm going to squeeze in 1 there. What's the square root of 1? It's 1. So let's plot these points now. So 0, 0, 1, 1. Then we have 4, 2. Then we have 9, 3. And then we have 16 is 4. And I don't have room for the 25. That's okay, I've got enough points. So when I connect them, I'm seeing it's kind of like a curve, right? So it's a curved shape. And that is true of all square roots. You get this curved shape. And remember, the reason why I didn't have any negative values is because we can't take the square root of a negative number. So I only included positive values here. So we get this curved shape for the square root function. I'm going to go on to the next slide now. So let's talk about the domain and range of a square root function. Keep in mind that I just graphed the square root of, or f of x equals the square root of x. That is the shape of this graph. That's what we graphed right here. All right, so describing the domain and range of a square root. So let's start with the domain. Remember that the radicand, that number underneath the square root sign, can never be negative. So that's going to help us when we go to find the domain of a square root function. So we're going to use that fact that the radicand, remember the number underneath the square root sign, so that means all of this underneath the square root sign can never be equal to a negative number. So to find the domain, what we're going to do for the domain is we're going to set the numbers underneath the square root sign, so just the numbers underneath the square root sign, and we're going to set them we're going to set them to be greater than or equal to 0, and then we're going to solve. So in this case, the numbers underneath our square root sign, because remember our numbers can't be negative, so that's why we're setting everything underneath the square root sign greater than or equal to 0. So in this case, the numbers underneath our square root sign are 4x plus 4, so we're going to set that greater than or equal to 0 to show that it's got to be a positive number or 0. It can't be a negative number. So all the numbers underneath have to be greater than or equal to 0, and then we're going to solve the inequality. So to solve for x, I'm going to subtract 4 from each side, and I get that x has to be greater than or equal to 4. So that is my domain. Is that all x's have to be greater than or equal to 4. And I actually meant to say negative 4. This should be negative 4. 0 minus 4 is negative 4. So in this case, our x values have to be greater than or equal to negative 4. So note that correction. That is a negative. I don't know why I missed that. So 0 minus 4 is negative 4, which makes the domain. The values that x can be would be that x can be greater than or equal to negative 4. So x can be equal to 4, and then anything greater than negative 4. So that's for the domain. So now to find the range, we're going to graph the function. And to graph the function, we're going to use the domain that we just came up with to make a table of x values, and then we'll plug in the corresponding y value. So let's start. I'm going to use negative 4, and then anything greater. So I'm going to do negative, I'll do negative 2, and then maybe something positive. I will do 1, and then maybe 5. All right, so when x is negative 4, I'm going to plug it into, remember our function is square root of x plus 4. So when I plug in negative 4 for x, negative 4 plus 4 is 0, and the square root of 0 is 0. When I plug in negative 2 plus 4 is 2, so it's the square root of 2. We'll check that with a calculator in just a sec here. 1 plus 4, when we plug in 1 for x, it's 5, square root of 5. And then when I do 5 for x, 5 plus 4 is 9. The square root of 9 is 3. So I'm just going to go ahead and put 3 in there. So what is the square root of 2? I'm going to grab a calculator so that we have an idea. It's 1.4. I just plugged that into my calculator. The square root of 5 is 2.2. These are rounded. So then let's go ahead and graph. So I made a very small little x and y chart or coordinate plane here. Remember y values, I'm going to stop there actually. So let's go ahead and graph. So negative, do it, how about in blue, our points. So negative 4, 0. Then we have negative 2, 1.4. So somewhere in there. We've got 1, 2.2, and then we've got 1, 2, 3, 4, 5, and 3. And then remember we get that kind of that shape, that half of a U shape. When we graph, we get a kind of a curved, it looks almost like a half of a U shape when we graph a square root function. So what are our possible y values? That's what our range is. Remember, is our possible y values, where the domain is our possible x values, where our range is our possible y values. So it looks like our graph starts here at 0. So that means that our range is going to be all, I don't know why I said it. So that our range is going to be that y has to be greater than or equal to 0. So our range is all of our possible y values. So keep that in mind. And that is how you find the domain and range. So again, the domain is all of our possible x values. Our range is all of our possible y values. And the first thing we want to do is establish our domain. We do that by looking at what's underneath the square root sign. So only what's underneath the square root sign. We don't include the square root sign when we're finding the domain. And then we take whatever is underneath the square root sign and set it greater than or equal to 0, and you solve that inequality. That's going to find your domain. Then you use that domain to help you find the range, because you need to graph the function in order to state the range, or your possible y values. And that's it. So you'll look at some more examples of that this week, of finding the domain and range. But last and not least, we can actually take our graph of square roots. I'm actually going to go back to this one that we graphed. We can actually take this graph and we can move it around. So we can move this graph up. We can translate it vertically. We can move it up. We can move it down. We can take a graph and we can move it right. We can move it left. So we can translate it, really. We can transform it, we can reflect it. So we can move graphs around. We learned that when we looked at quadratic functions. So we can take a graph of a square root function and we can move it about. So one thing I wanted to show you, though, is that when we graphed the square root of x, this is what we call the parent function, because we haven't done anything to it yet. It's just in its most basic form. So we call it the parent function. And the parent function is what we take and we move it about. So when we move our parent function, we can do it in a number of ways. So as I mentioned, we can move it vertically, we can move it horizontally, we can stretch it, we can shrink it. So this slide right here tells us how we can tell what kind of transformation occurred, whether it was up, down, left, right. So remember, our parent function is y equals square root of x. So really just this part right here, the square root of x. But we've added a whole bunch of things to it. And the things that we've added is to show you what kind of transformation has occurred. So for example, let's say I put a number out in front of my square root sign. So let's just focus on this green A. So there's a number in front of the square root sign. So if there's a number there, that means that a vertical, let's get a green highlighter, a vertical stretch or compression of that factor has occurred. So if it is less than 0, so if we have a negative in front of it, that means also that there was a reflection. So don't worry, this is all in the lessons this week, but this is a pretty cool slide. I like how it shows everything that can occur all in one slide here. So if you have like a 4, as in A, if you have a 4, that means a vertical stretch by scale factor 4 has occurred. If you have a 1/2, that means you've got a vertical compression because it's smaller than 1. So let's say inside the square root sign, let's say we squeeze a number in front of the x underneath the square root sign. So like we put a number here. So let's change that to red. So like we put a 4 in front of, whoops, let's use another 4. I just used another number. Let's use another number since I just used 4. Let's say the number 2. If I squeeze a 2 in front of the x, that means a horizontal stretch has occurred. If I said 1/2 in front of the x, that would be a compression. So that if we have a number in front of the x, it's showing a horizontal stretch or compression. If it's a negative number, that means we're going to reflect over the y-axis. So let's keep going. If underneath our square root sign, I subtract a number or add it, so if I were to subtract 6 from x underneath the square root sign, that means a horizontal transformation has occurred. And when it's underneath the square root sign, it's like opposite of what you would think it would be. So if I subtract 6, that means I'm actually moving my whole graph to the right 6 units. If I had plus 6, that would mean I would move the graph to the left 6 units. And then last but not least, if I have a number outside of the square root sign, like a plus 6 or a plus 8, do a different number, that means I'm going up 6 units. So the number outside the square root sign right here, if we have a number outside, it's telling us up or down. And that one is what you think it would be. If it's plus, it means up. If it's minus, it means down. And again, this is all explained in your notes, but this is just, or in your lessons this week in Schoology, this is just a very brief introduction to what I mean. So let me get a blank page up here. Like if I were to say the square root of, so let's say we have the original function right here, f of x equals square root of x, that's our parent function. And then we have a new function, g of x, which is square root of x plus 7. What type of transformation has occurred? Well, it's gone up 7 units. So from the original parent function over here, we would take it and move it up 7 units, and that's what this equation shows us. Here's another example. F of x equals square root of x, and then g of x is square root of x minus 1 all underneath the square root sign. So remember, this tells us there's some type of horizontal movement that's occurred, and it's opposite of what you'd think it would be. So in this case, we're going to the right 1 unit. So going back to the slide I was just on, if you want to take a look at, well, we're running out of time, so I'm going to stop there. Let's stop here with those 2 examples, and let's put up your key phrase assignment. So one of the things we chatted about in this recording is how to find the domain of square root functions. So I've put up a square root function, the function of f of x equals square root of 2x plus 2, the square root of x plus 2, and I want you to find the domain of that function. And that's it. Tell me what the domain of the function is. This function right here, what is the domain of this function? And I explained how to do it in this recording. Make sure you took good notes. You will have to submit your notes from the recording for your week 12 notes this week, so make sure you also took good notes as you watched. Remember, you can click pause to make it easier to take good notes. And that's it. So let me know if you need help as you work this week. Have a great rest of your week.